In section 3 of chapter 14, first we're going to look at the global test of the model. The global test is used to investigate if any of the independent variables have significant coefficients. That is, if any of the regression coefficients are not equal to 0. The null hypothesis is beta 1 equals beta 2, etc. equals beta k equals 0. So in other words, all the betas are equal to 0. And the alternative would be the opposite. Not all betas are equal to 0. We decide a level of significance, let's say alpha 0.05, and we select the appropriate test statistic by using F distribution with k degrees of freedom in the numerator and n minus k plus 1 degrees of freedom. Actually, it's n minus k minus 1 degrees of freedom, because this k plus 1 is in parentheses. Formulate the decision rule if the F statistic is greater than the critical F. Now, these are the results that we had from the previous section. We were using cost as the dependent variable, and these three variables, temperature, insolation, and age, as the independent variables, and the results were shown here. Now we're concentrated on the F statistic, which is this, the test statistic that is used to test whether all the coefficients are equal to 0. And to obtain that value, we divide the MSR, this value, over the MSE, this over this. And each one comes from, this one comes from SSR divided by the corresponding degrees of freedom, 3. And SSE divided by 16 is equal to this. So this one is equal to SSR divided by 3. And this MSC, is obtained by dividing SSE over 16, the degrees of freedom. Well, and the total degrees of freedoms are always equal to n minus 1. So we have 20 observations minus 1, 19. You can always look at it this way. The total degrees of freedom are equal to 20 minus 1, 19. But that is n minus 1. And the regression degrees of freedom is always equal to k, which is the number of independent variables. Number of independent variables. And in this case, it's 3 independent variables, temperature, insolation, and age. So that is equal to 3. All right, so total degrees of freedom equals regression degrees of freedom plus error degrees of freedom. So in other words, SSR plus SSE, the sum squares equals SST, right? We obtain. And in terms of, this is in terms of variation. And in terms of degrees of freedom, the degrees of freedom that correspond to total must be equal to, let's call this degrees of freedom total equals degrees of freedom from the errors plus the degrees of freedom from the regression. Well, this total degrees of freedom equals n minus 1. And this regression degrees of freedom is k, or rk. So how many degrees of freedom do we need for the error? Well, n minus, that is equal to this. So n minus 1 minus k should be equal to this. Okay? So you can just solve for the interrogation or the x, if you want to call it unknown, and subtract k on both sides. Then we can say the unknown is what? N minus 1 minus k, which is what you see in the in here. This is n minus 1, this is k, and this is n minus 1 minus k. So again, we obtain the MSR, we obtain also the MSE, divided this by this, and give us the F statistics. All right, which is this value here. And this is highlighted in green here, the same thing I just showed you. And the F statistic is the ratio of these two numbers, which is 21.901. Well, we have to compare this F statistics with a critical value of F. If you go to the table at 5% level of significance and degrees of freedom 3 in the numerator and 16 in the denominator, you should get a value of 3.24 as critical value. And then compare 21.9 to that. Is 21.9 greater than 324 so that we can find that value of F in the rejection area? Well, it is much larger than 324. So therefore, it is in the rejection area. So we reject the null hypothesis, which says that all the betas are equal to 0. And you can also look at the p-value, which is here on the column that says significance F. This is a p-value, is 6.5 with 6 zeros to the left. In this report here, you don't have enough zeros, so it's 0.000, and you can compare the value to 0.05. If it is less than 0.05, reject the null hypothesis. So we conclude the same. The results of the global test show that at least one of the independent variables is related to heating cost. In other words, one or more of the variables explain the variation in the dependent variable, heating cost. The global test is the first analysis of the multiple regression equation. If we fail to reject the null hypothesis, we will stop our analysis of the relationship between the dependent and independent variables with this sample n variables. It is possible that we will attempt a new study designed to predict home heating costs with different independent variables in a new sample of homes, because we fail to approve that even one of them will be different, or to accept even one of those coefficients. Instead, our finding of a significant relationship leads us to the next logical question: which independent variables are significantly related to heating cost? We just found out that at least one is not equal to 0. So which one is it? Or which ones are? These tests are, and we do now the individual regression coefficient. The null hypothesis is beta 1 is equal to 0, and beta 1 is different than 0. You apply that for the other ones. Beta 2 equals 0, beta, and the alternative beta 2 different than 0, etc. Level of significance, desired, the default value, 0.05. The test statistic is a t distribution with, again, the same degrees of freedom that are used for the errors, n minus k minus 1. The decision rule would be if that critical value, the critical value of t is greater than, if the test statistic is greater than the critical value of t. And that value of t is 2.12. You can confirm that in your table of a t distribution. Look at n minus k minus 1, 16 degrees of freedom, 20 minus 3 minus 1, that will be 20 minus 4, 16. 16 degrees of freedom and 0.05 two-tailed test. Recall that this is different than 0, so it's a two-tailed test. The value of t should be 2.12. That's our critical value. Now you calculate the test statistic for each coefficient independently, and you can see that the results in the table itself. The coefficients are minus 4.583, minus 1483, and 6.101. And right next to the coefficients, you have the standard error. And as you may recall from previous chapters, the way we calculated the test statistic was, let me erase this. The test statistic was, for the case of the mean, we calculated a mean value from the sample and subtracted the mean of the population divided by S over the square root of n, which we call the standard error. And in this case, the equivalent is our results from the sample is B1 or B2 or B3. Subtract beta 1 value under the null hypothesis, which is 0, and divide by the standard error. The standard error of, or the standard deviation of the B1. And that is your test statistic. Well, you take the temperature coefficient is minus 4.583. The standard error is right next to it, 0.772. You don't need to calculate it. And that gives you a test statistic, or t-stat, of minus 593.4, which is here too. And then do the same for the next one, minus 14.831 divided by 4.754 equals minus 3.119. And the last one, 6.101 divided by 4.012 equals 1.521. So notice this value is greater than 2.1. This value, the absolute value of this is greater than 2.1. The absolute value of the second coefficient is greater than the second test statistic, is greater than 2.1. And finally, the third test statistic is not greater than 2.12. So in this case, we reject the null hypothesis. In this case, we reject the null hypothesis. And in this case, we cannot reject the null hypothesis in the case of age of furnace. The test for each of the individual regression coefficients show that two independent variables, the mean outside temperature and inches of insolation, are significantly related to heating cost. The results also show that the age of the furnace is not related to heating cost. In fact, the results suggest that we can eliminate the age of furnace variable from the analysis. We then redo the multiple regression analysis without the age of furnace variable and calculate a new equation using only the temperature and inches of insolation variables. And these are the results, which we can easily do in our report here. We don't even need to drop anything. We just go over the same commands, and the dependent variable is the same, and the independent variables, we just select the first two and select output to be displayed beginning in that cell. Click OK, and that will be the new equation. 490 minus 5.14 times temperature minus 14.72 times the value of insolation, which is the same thing that is shown here in yellow. Our new F statistic will be displayed here, 29.424, which again is much larger than the critical value of F. And you can also see the significance using the p-value is very low, much less than 0.05. So, and the R squared, the adjusted R squared is 0.749, indicating about 74.9% of the variation in heating cost is explained by the two independent variables that we are using now. So we obtain a new equation, and it looks a lot like the previous ones with the negative coefficients, and the two, of course, are significant. And but the numbers are a little bit different, but the main idea is the same. So that is the end of section 3 in chapter 14.